Hello, everyone, and welcome to our webinar, How to Build an LLM App on Inventory, Product, and Reviews Data. My name is Matt Brown, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. If this is your first time joining a single store webinar, heads up that we present weekly technical workshops and webinars demoing data and AI use cases and new technologies. In fact, on Thursday of this week, 2 days from now, we'll be presenting how to build a full stack AI app in React with the Elegance SDK. During that time, our team will present a demo on how to build a React app in minutes, where you can upload books, document files to your application and database, and then have an intelligent conversation with the books information. It's very cool. I've seen it from Yaroslav and Madukar. I think they uploaded Phantom of the Opera and like a couple of the classics books. So it's a very cool little application and demo. So if that topic sounds fun to you, feel free to register right now. Bit.ly React AI webinar. You can see that bit.ly link on your screen, that QR code. Feel free to take a photo of that or a screenshot of that. I'll also put this information in the chat in just a minute. But back to today's topic. FYI, we have fantastic technical experts who are joining our Zoom Q&A, who have a good grasp of the technologies involved. They're ready to answer your questions interactively. We will try to get to as many of the questions as we can as they come in. We have a big audience today. I will also flag a few for the live Q&A with our panelists at the end of the session. One more note here, we'd love for you to try out today's technology. In fact, anyone who tries it today will be entered for a chance to win new AirPods Pro. All you need to do is click that link or take a photo of that. The link is bit.ly LLM app webinar raffle, or take a photo or screenshot of that QR code on your screen. And all you'll need to do is log in to Single Store, either a free trial if you're a new user, an existing account if you're already a customer, or an ongoing trial. We're going to check back with the folks who have come in through that link, and we'll announce a winner by the end of today's session. So let me introduce our speakers for today. Akmal Chowdhury is a senior technical evangelist at Single Store. He has strong expertise in big data, machine learning, and AI. He is a prolific author and regular speaker at our weekly webinars. And then David Day Matthew is a co-founder of Noom AI, which was a Y Combinator backed startup from the S23 batch, dedicated to simplifying the process of building LLM applications. He has a prior background in product and program management at Microsoft, and we are very excited to hear about David's new venture that allows AI engineers to connect data sources to their LLMs through retrieval augmented generation. Welcome, both of you. Akmal, I believe you have the floor first.
Great. Well, thank you very much, Matt, and thank you, all of you in the audience, for joining today. As always, I always do a time check. So it's just gone 6 p.m. my time here in London. I think we are due to change our time, daylight savings, from Sunday next week. So it's going to be probably earlier until the US catches up again. So thank you again for joining wherever you are. Good morning, good afternoon, good evening. Okay, so I've just got a couple of slides really just to say a few words about Single Store DB, and then I'll hand over to David. So he will do all the interesting stuff in terms of showing his technology and how to use it. So a question that's commonly asked is, what is Single Store DB? Well, it is a relational database management system. It is a distributed relational database management system. And so what you've seen over the last 10 years or so is the development of these various distributed relational database systems. So go back in time, 10, 20, 30 years, and essentially is monolithic relational database systems that were around. Some of those products are still around today. But the thing is that look back in time at the time when, Hadoop was being developed, Spark, and so on, this idea of MapReduce, and using scale out versus scale up, and the opportunity to really take advantage of cluster computing, bring the processing to where the data are, and stop the movement of data essentially. And this is really what we've seen over the last 10 years or so in terms of development of relational database systems. So taking advantage of some of the ideas and the developments that occurred in NoSQL technology, and really continuing to evolve the SQL and relational sort of products. The other thing that SingleStore is very good at is that originally started live as OLTP, in memory only technology. MemSQL, you may have come across that. And then a few years ago, change of name, because now there is a focus also on analytics. So adding columnar storage and the ability to really, do these operations, sum, min, max, average, count, all of these things at scale upon the data. So combining both of these, both OLAP and OLTP. And architecturally, here's a kind of a nice diagram that really shows this. So we have this concept of universal storage. Okay, let me just get my arrow here. There we go. And this really combines both of these requirements in terms of storage, being able to manage these two types of data, both the OLTP and the OLAP. And surrounding this, we have a variety of technologies that we can connect with. So it could be streaming data, for example, maybe using something like Kafka. I use that from time to time. If you attended SingleStore Now just last week, you'll know that I presented with my colleague Arnaud, and he was using Kafka a lot in demonstrating pipelines and how we could ingest data at scale into SingleStore DB. Transformations as well. So here we've got one example. This is using Spark, as you can see, the logo. And then there's a variety of other technologies as well. Some of these you may recognize, things like Hadoop, for example. So can integrate very well with these external tools and technologies. It works and plays well on any of the three major cloud platforms in the Western world. So AWS, Google Cloud, Microsoft Azure, and you can also run it on-prem if you wish. And there is a Docker container as well. So that's a very low cost, low risk way of just testing out the technology if you want to, and then just trying it out without having to do very much, really. I mean, just, you need the Docker environment, obviously, to be able to utilize that. One thing that's worth noting is that in the link that Matt shared in the slide just a few moments ago, once you've registered and you've got an account on the SingleStore portal, there is a section there that allows you to take the license that's generated for you, and you can utilize that license with a 4-node version, up to 4 nodes, and you can install that in your own environment. That can be on-prem, it can be in the cloud if you have some kind of cloud-based environment. And that is a full version, okay? We do have customers actually using that as well at the moment. So that is one possibility. But the cloud-based environment is great because it gives you the chance to just sign up quickly. There's nothing to install locally. You get $600 worth of credits. And, if you're thinking, well, $600 is not very much, well, consider this, that I joined the company nearly 2.5 years ago now, and I created an account on the portal, SingleStore portal, just before I joined. And even today, I still have outstanding credits that I use occasionally. So if you're very careful, shut down resources when you don't need them. It's a great way to be able to continue using the technology. And there were some great announcements made as well last week at SingleStore Now in terms of some of the other sort of benefits and other capabilities that we're going to be offering developers soon in terms of providing some, sort of free account and resources there. So you don't have to utilize the credits. But until that comes on stream, I mean, this is a great way to continue using that. Okay. As I mentioned before, it is a relational database system at its heart, but it supports a whole range of other capabilities, multi-model as we would probably classify them. So things like geospatial, for example, and I've written about those capabilities, time series as well. Even you could use it as key value if you want to. Full text search, that's supported through the Lucene search engine. Okay, so that's built in as well. And what is probably more relevant today, and certainly has been for the last maybe 6 to 8 months or so, is this concept of vectors and storing these vectors, generating these embeddings from the likes of OpenAI and similar technologies, and being able to have the database store these and then doing these kind of semantic searches. One important point, keep in mind that vector support in single store has been around since 2017. So it's not something we just added today or yesterday or recently just because it's something very popular. It has actually been in the product for quite some time. Now, there are some additional things that are happening in that space. And again, there were some announcements made at the conference in San Francisco last week that we are building upon the capabilities of vectors, and some very cool stuff is coming along in the very near future. Okay, so watch out for that. Okay, so finally, applications, real-time decisions, IoT, dynamic experiences. Many of these we've covered through webinars throughout this year. And then the integration with dashboards, the ability to run ad hoc queries, very, very straightforward. I mean, there's a built-in SQL editor if you want to do that. ML capabilities as well. I mean, if you think about it, the vectors, there's support for dot product, Euclidean distance. You can do cosine similarity as well. So if you want to, you can run these machine learning ML operations directly within the database system on the data. Okay, it's not something you have to implement externally. JDBC, ODBC support. And then lastly, I think the important thing there is that it is MySQL wire compatible. And also it is MongoDB wire compatible with the addition of single store Chi earlier this year. Okay, so that is very, very useful going forward. Very quickly, just to kind of summarize some of the capabilities. So we do let me just get my box here. So row-based, okay, great in memory, distributed SQL, horizontally scalable. We have the columnar support as well for aggregate functions, and super fast ingest for pipelines. Okay, it's a great way to connect things like Kafka, for example, or some streaming source if you want to load the data in, excuse me, at scale and be able to run operations on that. And then the other things such as vectors, okay, which we touched on just a few moments ago, the semantic search capabilities, of which I think David is going to go into more detail there. And the other thing is that given the Lucene full text search engine that's built in as well, you can combine the semantic search with the keyword search as well. Okay, so that's a great sort of addition as well. Gives you a lot more flexibility in terms of how you access your data and the sorts of queries that you can run. And last but not least, if you are familiar with Jupyter Notebooks, then we have this notebooks capability as well. Again, that's built into the environment. It's not something you have to install externally. You can run that in a browser and connect to your database, be able to run machine learning operations, work in Python, and so on. I mean, it is truly very, very useful and extremely productive because it combines everything that we have within that environment, and it's not something you have to download or install for yourself. Okay, so with that, I think I will just finish there, and I'll hand over to David now. So I'll stop there and stop this share and let David access and be able to share his content. So over to you, David.
Perfect. Thank you so much, Akmal. Hey, everyone. Great meeting you all. Just sharing my screen. Let me know if you can see it. I think it should be shared. Perfect.
Looks good.
Okay. Hey everyone, my name is David. I am the co-founder of NoomAI. NoomAI, we are a data platform to help you generate embeddings. As Akmal was talking about, with vector search becoming more and more important, with retrieval augmented generation, we really become a platform that helps you take your data and go through the process of embedding it into vectors so that you can leverage it as part of your LLM applications. And you might ask yourself, just to kind of get us started, like, why would I want to do that? And I have here just like a funny screenshot of like a question I asked ChatGPT about. I'm a Real Madrid fan, so I was asking it about some results about some games. You know, when we look at these large language models, they have a lot of information. They're really smart, but at the same time, they don't always have necessarily the most up-to-date information, or they don't always have information that might be pertinent to a specific realm. Like if I were to also ask it about, let's say, what did a customer say in a call yesterday, or ask it about a meeting or a document that's proprietary to me, it's likely that these models are not going to know about it because they haven't been trained with that data. And that's really where retrieval augmented generation has been making strides in helping you make sure that you don't always need to fine tune or retrain these models to be able to get new information into them. Instead, we can contextualize them by retrieving information and providing it back to those models so that they know about it. And at a high level with retrieval augmented generation, we generally start with some type of knowledge base, whether it's like documents that are internal to your business, customer data that's unique, or your own business data that we want to be able to take in and provide into these models. And so we set up a retrieval augmented generation pipeline that takes these data, processes it, generates vectors out of it, and then stores it into a vector storage location, so that then we can retrieve that information using HNSW or different retrieval algorithms to be able to provide that information back into those models. And so in the example that I was talking about before, you know, if I were to have information about the game or have information about that last week's meeting, I'm able to take that information, put it into a vector database, and then retrieve it at runtime to be able to contextualize the information that I'm passing into these large language models. And today we're going to be focusing specifically on leveraging single store kind of across the stack, and showing you how it works with NumAI hand in hand. To tell you a little bit about NumAI, so as I mentioned, we are a platform that helps you generate embeddings out of your data and then put those vectors into vector databases so that you can retrieve them at runtime. And so we support different types of connectors in between those a single store where you can pull information from. We then support different embedding models that you can leverage to be able to generate those embeddings, and we generate those embeddings at a really high scale. And you can leverage all the way from like out of the box models like OpenAI, all the way to open source models through Replicate or Hugging Face. We then support different vector storage locations where you can drive those vectors into, so that you can then be able to do retrieval of those vectors. And then most importantly, when it comes to our platform, we support these capabilities with the concept of synchronization in mind. Because one of the things that we have found to be really important in the process of doing retrieval augmented generation is that it's not only about connecting your data once, it's really about making sure that your data is always staying up to date. Because no one wants a bot that maybe has the right answer today, but doesn't have the right answer tomorrow. And we want to make sure that we're doing that in the most efficient, optimized way possible. Now I'll deep dive a little bit into the platform, into how it works, before we head into a couple of demos that I have ready. At a high level, our platform starts with the concept of fetching. So we start by being able to connect into these different types of databases that handle your information and fetching that data down into our platform. Within the platform, we have a distributed system that will parallelize the ingestion of that data, down to also the process of loading it, chunking it, and augmenting it. These are all operations that can be expensive from a compute perspective, not only because the amount of data might be large, we're talking millions of rows or millions of documents, but also because the level of augmentation and chunking that we're seeing these days being done to be able to get a really high quality level of retrieval requires a lot of computation. And then the embedding itself is really the next piece, where we also have some distributed system to be able to help us to reliably generate vector embeddings. These embeddings, again, they're also very high compute intensive, as if we're basically running ML models for every piece of data. And then these embeddings are also really where the quality of the application will lie. And so making sure that those are getting generated correctly and that we're also being efficient at how we're generating them becomes really important. Finally, we ingest all that data into your desired vector storage, and make sure that that data is also well organized from a metadata perspective. Because one of the other things, and we'll talk a little bit about this in an example later, is that it's not only about just throwing vectors into a vector storage. It's really about making sure that you're organizing those vectors for optimizing the retrieval process. If you just throw vectors in and you query them, you're going to get a decent answer. But if we're able to provide additional context into those vectors through metadata that can help us be able to filter the vectors that we're looking through, that will help us improve the quality quite a bit. And we'll see this in an example just in a couple of minutes. As I mentioned, one of the other really focuses for us as a platform is the idea of synchronization, because it's not only about, again, putting your data in once into a vector database and forgetting about it. It's really about making sure that your data is continuously being updated and continuously being correct. And so we support a couple of different ways in which we're able to detect changes coming from data. You might be familiar with like traditional data synchronization like CDC. We also support more simple methods like scheduling and triggers. But at a high level, we want to make sure that we're listening into a bunch of different eventing mechanisms to pull data into vector databases and making sure that those vectors are being updated. More importantly, though, the regeneration process of embeddings can be tricky, and it can also be expensive, especially if your data is continuously changing depending on what your underlying sources are. And so making sure that we're being optimal at how often we're regenerating embeddings becomes kind of interesting. What I think is like most interesting about that specific piece is that a vector embedding is only a representation of the underlying data. And so even if the data changes, it doesn't necessarily mean that the vector needs to change necessarily. And so that is where we're working on optimizations to help really lower the amount of times that we're re-embedding data, and only really re-embedding that data if it's necessary. This will help with costs as well as maintain the quality of the application. And then finally, when it comes to updating the memory, making sure that we're keeping only the right vectors in place becomes really important. We want to make sure that there's no duplication of vectors, for example, because if not, you're just going to get the same answer or the same chunk over and over, and that's not super helpful. We want to make sure that the proper metadata is being appended to every vector, and that we're doing asynchronous jobs to augment that data over time. And also, we're also thinking about what it means to delete data, because the reality is that it's not only a game of adding and adding and adding, but also deleting data whenever it's necessary, even whether because vectors might be out of date, or because they've been updated with something new, or maybe because those vectors are actually not being used, or the quality of them is not good, and being able to clean up those vectors. So that is another piece for us on the platform. So that was kind of an overview of what we do and why we do it. Now I want to go into a couple of demos to showcase how the platform works and how it works specifically with single store. So in this case, we'll start with the first example where I'll be treating single store as a vector database. So we're going to be leveraging the vector capabilities of single store to move external data into single store to then do retrieval augmented generation on top of it. So in this case, what I'll be doing is I'll be pulling some data out of Twitter using API, and we're going to be driving that data into single store. What will be cool about this is, so I'm going to be querying Elon Musk's tweets. He tweets a lot, so we have a lot of content out of it. We'll be scraping those tweets, going through the process of embedding them, and then reliably moving them into the vector store so that they can be retrieved. So let's change screens here for a second to walk you through what we're going to be doing. So the first thing I just wanted to kind of do a quick quick mention of is I'll be leveraging a number of our APIs to help me with this. Specifically, we're going to be creating a new AI pipeline that's going to help us with the data movement that we're going to be doing. Here, this is our documentation. We'll share links to some of this information later. But here you can see kind of the full set of connectors that we support. Today, we're going to be focusing on the API Twitter connector that will help us pull data out of Twitter, as well as we're going to be focusing on our single store connector to help us move data back into single store. So that will be pretty neat. And sorry, this is the Zoom bar always gets in the way. And so to get us started, the first thing that I will do is I'm going to go ahead and create a table that we're going to be moving our data into single store with. So this is a pretty simple table that we're going to be creating. It has an ID, it has a text piece, as well as a source that we're going to be adding for metadata, and then obviously the vector. And so what I've done is I've actually just generated that already here. It's empty right now, as you can see, and we're going to be moving data into this in just a second. What we're gonna then do is I'll open Postman here, and I'm gonna craft up the pipeline that we're gonna be leveraging. So the pipeline will, as I mentioned, will leverage our API source to help us move
data. David.
Oh, sorry,
David. I don't know if you're sharing your Postman screen yet. I still see your slide. Maybe that's intentional. I don't see your actual screen share yet.
Oh, sorry, let me. Oh, my bad. I thought I was sharing my full screen, and I wasn't. So sorry.
All good. Okay, I can see your screen with the code now.
Let me actually then backtrack a second so that I can talk to what I showed before, and I thought I was. Thank you, Matt. Just backtracking a little bit to make sure that everyone saw it. So the first thing I just wanted to share here was just a glimpse into our documentation for NumAI. So here, we're going to be leveraging today a couple of our different REST APIs to help us generate a pipeline that's gonna take data from the source and move it into the vector database. Today, we're going to be, for this first example, we're going to be leveraging Twitter, where we're going to be extracting tweets out. And then we're going to be leveraging the single store integration to be able to drive vectors into single store later. And so to get us started, the first thing that I'm going to go ahead and do is create a table for the tweets that we're going to move in. And so this is the table that we're going to be creating. It has an ID, it has text, and it has a source. And I have it already here created already, and you can see that it is empty. So you can see that I just created that simple table. The next thing that we're going to do is now we're going to go into Postman, where we're going to craft the pipeline that we're going to be leveraging. So as I mentioned, we're going to be using the Twitter source, and I have it set to Elon Musk. So it's going to be getting us our Elon Musk tweets. We're going to be using OpenAI for our embeddings. But again, we support both closed source as well as open source models that you can bring in. And then finally, we're going to be leveraging single store as our sink. And we're pointing it right into that table that we just created that is called tweets. So I'm going to go ahead and run this pipeline, and we'll see you in a second. So the pipeline has been run. We have a new pipeline ID that has been generated. And what I can now do is I can come in here and check the status of our pipeline. So we're going to take a look, and it looks like it is running right now. So we're going to give it a couple of seconds to run through. It shouldn't take too long. The pipeline will go in, it'll scrape out the information out of Twitter, and it'll bring it into single store. And while that's running, I'll maybe just showcase for a second kind of so we support both the ability for you to hit our REST APIs directly. We also support the ability for you to build these similar pipelines directly on our platform. So if you want more of a no-code solution to do this, like we support this too. And so, if I were to go craft that same pipeline that we just generated, I could do the same by bringing in the different pieces and building out the pipeline similarly. So we also support the ability for you to do it this way. Really depends on your preference. I'm more of an API guy, so I like Postman, but if you are into more drag and drop, this is also something we support that you can leverage. So let's check our pipeline again and see if it's done running. Oh, it looks like we had a failure. Looks like a tweet might have been duplicated. Let's actually do that again. This is what I love about live demos. Just delete the table real quick and run it again. Oh. Okay, and let's run that again. Make sure it's empty. Yep, should be empty. Yes. Correct. Let's run this again. Okay, so we have a new pipeline. Okay. Perfect. So we have our pipeline running again. This will take just a couple seconds to run through. And again, it's just gonna do the same pool that we did before, bringing in the data from Twitter into single store. And we'll just check this to grab it when it's done. We should actually be able to even see some of the data kind of coming in as it happens. Okay, so it looks like our pipeline actually finished, and we now have all of our tweets in here. So as you can see, we've pulled in about 47 tweets from Elon all the way in here. You can see that we have the vectors generated for it, which is pretty cool. And now I'll show you what it looks like from a retrieval perspective. So what I have here is I've set up a very simple chat interface where we're going to be adding our context into. And so I'm going to add the pipeline ID that we generated, and we're just going to play around with it for a second. And so we will ask, what does Elon think about X? And let's see if Elon, I feel like he tweets a lot about how much he likes X. So let's see. So it looks like Elon has tweeted that he finds X to be much better than legacy media propaganda. Okay, sure. But more importantly, what we can see is actually the context that we're pulling in. So out of all the tweets, out of the 47 tweets that we had, we pulled in a couple of them here that were the most specific to the topic in hand. You can see that actually the first one that was pulled in seemed to be quite relevant in terms of like what he likes about X. So that's pretty cool. And again, we can ask other questions and get answers. And here behind the scenes, what we're doing is that now that we have all this data right in single store, we're just doing that product, the dot product out of those vectors to get those cosine similarities, so that we can actually know how close our query is to these different tweets and pull in the tweets that make sense. So that's the first demo that I wanted to show. The second thing that I wanted to go into was actually doing an example where we leverage single store across the board, because it is very likely that many of you might already have data in single store today, and you might want to be able to leverage that data to be able to pass it as context into these RAG applications. And so specifically, the concept that we're going to be doing is around product listings as an example. So we're going to pretend for a second that we're a grocery store and we have all of our product listings on single store. And we have a bunch of products, and we want to build some type of application for our users so that they can ask questions about food. Like they might want to know how I get ideas for specific meals. They might want ideas of what to do with certain products. They might want examples of products that they could buy. And so to do this, the first thing that we've done is I've created like a very simple product listing table within single store, and we'll take a look at it in a second, that has a couple of fields to it. The first field is it has a product ID, it has a name, a description, and then it has the price, quantity, and category for it. And so the first thing that we're going to do is that out of all the fields that this table has, we're going to be focusing on embedding two specific fields, the name and the description. The reason that we're going to embed those fields is because those fields are the ones that have the most semantic meaning around them. Something like price doesn't really have a ton of semantic meaning versus name and description do. What we're going to then do, though, is that we're going to take the rest of those fields, the product ID, the price, the quantity, and the category, and we're going to add that as metadata so that we can actually filter the information by it. And so here we'll go back over to our demo, and we'll go here in single store. And as I mentioned, I have already pre-generated a product listing table, and you can see it right here. We have 30 or so products that you would find in a grocery store that we have added into this table. You can see that we have the name, the description, the price, the stock quantity, and the category. And what we're going to now do is that, similar to what we did before, we're going to be now moving the data from this single store table into another table where we're going to be vectorizing it. One question that might come up as I'm doing this is, David, why are you creating a different table to put the vectors in versus just adding the vectors into the same table? And the reason that we're doing this in this example is because in this case, there's two fields within this table that we want to vectorize. And so assigning a single vector to an entire row doesn't really work for us right now, because there's going to be multiple vectors per row. If you had an example where you're maybe only generating one vector per row, maybe that would be okay. But in this case, we want to generate two vectors per row. And so we're going to create a different table to handle that. And so we're going to go ahead and, very similar to what we did before, we're going to be leveraging out of our connectors. We're going to be, instead of using the Twitter connector, we're going to be using our single store connector. This connector allows us to be able to pass in a query that we're going to be using to extract data, and then it allows us to pass in a couple of different values. The first one is an ID key. That will be whatever unique ID we have on the table. That will help us for some of the deduplication as we're doing synchronization of data later on. And then two sets of keys. The first one is what the values that we're going to be embedding, name, description. And then the others are the metadata keys, the additional information that we're going to be appending to the vector. And so, and then we're going to be leveraging the same sink that we were using before, the single source sink, where we're going to be driving the information to. So to get us started, I have already gone ahead and generated as I mentioned, the product table. And then I've gone ahead and generated a second table that is where we're going to be putting our vectors. Our vectors, as I mentioned, we're going to be adding some metadata to them, specifically the product ID, the name, the price, and the stock quantity for them. And so I've already gone ahead and pre-generated this table that you can see right here. So this table is completely empty right now, and we're going to be adding data into it. The next thing is, now we're going to go back to Postman, and we're going to go ahead and craft that pipeline. So the first thing we're going to do is we're going to call out the source. Our source, as I mentioned, will be that table that we just created. I've added a query that just selects everything from that table, but you could have a query that's a little bit different, that only selects pieces of it, or whatever information you want out of it. We also have the key ID, which is the product ID itself. That's the unique identifier that we have in the table. And then we have the embed keys for the name and description that we're going to be embedding. Those are the values that we're going to be generating vectors out of. And then metadata keys for the other columns that we're just going to be adding as metadata into that vector. The next thing is, similar to what we did before, we have added our embedding model. We're going to use OpenAI as well for this one. And then finally, we have configured our sink with the table that we just created to be able to add the vectors into it. And so we're going to go ahead and run this right here. And we can see that it is running. And what we're going to go do is we're going to go, again, check the status of this. One thing that I'll mention is that for single store, we have, as well as for some of our larger scale connectors for data, we have a bit more information that we share on the actual running, as we're able to, as the tasks are getting distributed, and we're moving through the process of embedding all the data. So you can see that now the pipeline has completed. So yay. And we can come back here and let's refresh this. go back here, and we can see we have actually 60 vectors that have been generated. As I mentioned, each of them will have the text of the embedding, but it'll also have some metadata about the product itself. Like the product would be the name, the price, and the quantity. What we can then do now is similar to what we did before, is that we can go back to our little chat bot and chat a little bit with this data to see what it has to say. So I'm just going to copy out the pipeline ID that we have for this and come back into our little tool here to talk. Let's actually refresh this. Okay. Perfect. I'm just going to need my. So now let's ask some questions. So let's do something like, what recommendations do you have for breakfast? And we can see that it is recommending us some oat flakes or classic cornflakes, which are some of the examples of information that we have within the vectors that we've generated. But then, like, what's cool is that I can then ask maybe even more abstract questions, like, what if I wanted to add protein? And here, like, I'm getting a bit more abstract, where I'm starting to ask questions that might be less direct, and where you can see that we're pulling in information about, for example, yogurt that's also in the list of products that we have. And so here you can see where, like this full example where we're taking data that you might already have within your databases, whether it's your product listings, it could be user reviews, it could be any type of information that you have within these tables, and we're making it accessible and building features that make users have a better experience against your company or against your product directly. One thing that I'll also mention is that, today, like in this example, I focused mostly on single store, bringing the data in from single store, but similar to what we did with Twitter, one of the cool things about Noom is that we support a number of different sources. You can even combine them together into a single pipeline. And so, if there's like recipes that maybe are online that could help us like make it even better, or we have nutritional data that we want to bring in, or even customer reviews, for example, for the different products, all of that is information that we can bring back into our vector stores and be able to augment even further the retrieval process that we have. So that is maybe something that we can do in a later demo as we go deeper. Cool. So yeah, that's kind of the end of my demo. Really like hoping that like really emphasizing on this idea of being able to take existing data that you have on single store or any other data stores that you might have, bringing that data into your vector storage, and then using Noom to help generate those embeddings, as well as helping with the synchronization of it, so that we can help you make sure that your data is always being kept up to date. Perfect. So thank you so much for the time, and I'll hand it back so that we can do some Q&A.
Awesome. Thank you, David. This was awesome. We will now begin the Q&A session. We have way more questions than we could ever answer live, but please keep them coming. We'll try to get to as many as we can. We're also going to follow up with folks via email if we can't get to something live. So just a reminder, Q&A functionality in the lower section of your Zoom console. I've collected some for David and Akmal. I also hear that Eric Hansen might be joining us late to help with some of the digital questions. So I'll start with you, Akmal. There was a couple questions about single store, on-premise, questions about NoSQL, relational, vector. Can you just quickly talk about that, how single store positions itself?
Yeah, so single store is a multi-model database system, as we kind of discussed at the beginning of the presentation. And so, I mean, at its heart, it is a relational database system, yes, but those capabilities that we talked about, geospatial, time series, vector, I mean, these are all part of the core engine. They are not simply add-ons or layers or something. And so that means that they get updated and developed as part of the overall offering. Now, one of the ways that the best ways to get started is to use the cloud-based environment, simply because there's nothing to install. I mean, just create an account, and then you just provision whatever resources you need on one of the 3 major cloud providers. So that is within a couple of minutes, you can have a workspace provision, you can be up and running, and creating databases, working with SQL, very, very easy to do. You can install it on-prem, as we discussed. That's possible too. But if you're new to the technology, as I said before, the easiest way is to create the cloud-based account on the portal using that link that you provided, Matt, and people can get up and running literally within about 2 minutes. I mean, it's a simple sign-up process, and that's a great way to get started.
Awesome. Thank you, Akmal. David, there was a couple of questions for you about pricing. Is this a cloud subscription, or how does your pricing work?
Yeah. So Noom, it is a managed cloud service today. We have started to get some requests around like on-prem deployments and things like that. And so that if that's of interest to you, would love to talk. So today it's a managed cloud service. We really charge depending on the amount of data that we're moving. So it is consumption based, the model. And it really depends on how much data we're managing on your behalf, essentially.
Good stuff. David, couple of questions about Noom. One was how good are you with large amounts of data? Also, how do you define high scale? Could I send 100 million transactions?
Yeah, that's a great question. So today we're moving already kind of in the ballpark of billions of vectors every month. So we have built a system to be pretty scalable from that perspective. Our distributed architecture makes it so that we can always kind of add more resources to help with really large data moves. So that there's no really big concerns kind of on that side. And then when it comes to kind of the synchronization, that is like, because part of what is kind of interesting is that if you're gonna take like, let's say 100 million rows and move them in, that's like a one-time thing that we're gonna move the vectors in, and so we can scale pretty easily to kind of support that initial move. Then I think that the more important question is kind of like, what is the recurring amount of data that you're expecting to continuously synchronize, and where we're able to again support kind of in the millions of rows, like size for that.
Good stuff. David, I'm going to give you one more, and then I'll jump over to Akmal and Eric. There was a couple questions about embeddings. There was one was, can I fine tune my embeddings? Some were about like which embeddings are better, OpenAI. What about I'm running out of tokens? So I wonder if you could just talk about embeddings for a little bit.
Yeah, that's a great question. So I think that on the question of like what embedding model is best, like it really depends on your data. And so generally, we have a couple of tools that maybe I can briefly touch on or link here, where we help kind of try to figure out what the right embedding model is for a given piece of data. And so there is a little bit of back and forth testing that needs to be done to kind of like land on what the best embedding model might be for given data. The other thing to think about is when it comes to like the latency of embeddings that you're looking for, because depending on what your latency is, there's also kind of different requirements on the embedding side. Things like OpenAI, we really like OpenAI, not only because the quality is relatively okay, but also because they provide like a really high throughput way to create embeddings. If you're going to be using some of these open source models, there is kind of the thinking that needs to go into how to actually go about hosting and leveraging some of those models. And today we partner with companies like Replicate and like Hugging Face to do these types of hostings. But depending on what your latency requirements are, like that might not be an option, because some of these models, even though we put them with large GPU clusters inside of Hugging Face, they're still going to be potentially slower than OpenAI in generating embeddings. So there's kind of a question there as well. And then like in terms of like the actual like generation and like fine tune of the embedding models, that is something that we do not support today yet. It is something that we're thinking about, and like given that we help with the retrieval, then it kind of makes sense to be able to leverage the retrieval to then inform how these models are being trained. I think that the one thing I'll mention though is that I think that like there's a bit of like maybe like I don't know if it's the right word to use, but a little bit of an obsession around the idea of like fine-tuning embedding models and like fine-tuning models in general. I think that one of the things that we have seen though is that specifically when it comes to the RAG pipelines, it is also as important to make sure that like the pipeline itself has been optimized. And what I mean by that is like that the loading is really good. So if you have different types of documents or the different data types, that those data types are being loaded correctly. The chunking mechanisms tend to also play a really important part, where if your chunking is bad, it is almost certainly going to lead to a bad result down the line. And so there's a couple of those other levers that can be pulled and can be worked on that don't necessarily require you to go train an embedding model right off the bat. Embedding models, again, it still will be important over time, but you know there's a couple other levers that you might want to pull on before you go down that route necessarily.
Good stuff. Thanks, David. Akmal, or you're welcome to hand any of this over to Eric if you prefer, but there was a couple questions about single store security with sensitive data. There was also a question about how does single store prioritize access control? Is single store cloud HIPAA compliant? Wonder if you could talk about those topics.
Yeah, Eric will know far more than this, but I think I answered some of those questions, Matt. So yes, HIPAA compliant. There's a link to the documentation that talks about that security. Role-based access control. That's a great way to, prevent people that you don't want to see certain data. You go very fine-grained control. Those are great ways to manage all of that. And, maybe Eric has some thoughts as well. So I'll hand over to him. He knows far more about the product than I do.
Yeah, and we have a model for, granting permissions to tables, to different users, groups, and roles, and controlling access to, something that you would expect from a, enterprise relational database.
Good stuff. I've got another one for you, Eric. Let's see, where was it? Oh man, I lost it. I don't know. Was there, Akmal, did you see one while I try to track this one down? Did you see a favorite one that you answered or want to make sure that the community hears?
Yeah, I think seem to be quite a few questions there for David on, can you install it on-prem kind of thing? Is it necessary to use your cloud-based environment? And then things like tokenization and fine-tuning, all of these kind of issues, which I guess is very important for, many users out there. They're just wondering what more they can do with a product beyond just what David was showing. I don't know if you have some thoughts on that, David.
Yeah, there were a couple different topics in that question. So, so from the first one, from an environment perspective, so today we run the platform as a managed service, but it is possible to deploy it out to on-prem or on cloud solutions. So that is something that we definitely support. On the tokenization and fine-tuning side, it is an area that we're a little bit earlier on, and so we don't have yet like a lot to show there. But at a high level, part of our thinking has to do with the fact that once you have the ingestion really well, like you have really good ingestion of data, you're doing great chunking, loading, and embedding, and you have your data going into a vector store. The next step that we're thinking about is really retrieval. So at retrieval time, we're focusing kind of on the first steps, which is being able to search my data, being able to use metadata to filter that search. But then the next step, which is where part of where we're heading into, is this idea of like what it means to evaluate retrieval and know whether the retrieval that was done was correct or not. From that perspective, then is where we start to see kind of the potential for us to help with fine tuning, where if we control the pipeline, we know how things are getting moved in, and we know what metadata is being associated to each piece of each vector, and we know what the vectors are and how they're getting created. If we're then able to evaluate the retrieval and know that the retrieval was good or bad, we're able to then kind of like backtrack that information into the pipeline. And this is where, like, for us, like it's not as easy as an answer to say like, oh, we're gonna take the data and fine tune a model with the data, because we think that there's other optimizations that can be done with the data as well. And this is where, like, you know, from our perspective, there might be some cases where taking the retrieval and understanding where it failed could lead us down a path where we go and we maybe improve chunking, for example, or improve loading of the data. It might lead us to a place where we do go out and improve the embedding model. And improving the embedding model might take a couple of different shapes or sizes. It could be that we simply change models because maybe there's a different model that might perform better, or it might be that we go fine tune the model. So those are all kind of like possibilities that I think come out of the ability to evaluate the retrieval. And it is kind of like I think that the next step for us within our roadmap to start taking a look at.
Very cool. I think we have time for one or two more questions before we do the AirPods raffle winner. Eric, I'm going to give you this one. There was a question, does Single Store have a Snowflake integration? If not, how do you compare and contrast with Snowflake?
You know, you can, there's not a specific Snowflake integration, but you can, of course, move data back and forth between Single Store and Snowflake. So Snowflake is a data warehouse database product and service, and Single Store is a general purpose product that can do analytics and transactions and contextualize information with vectors all in one place. So yeah, there's many different ways to move data in and out of Single Store, and that you can move between other database products like Snowflake. You know, you can select into Outfile, for example, or select into S3 and then load data from there to another product like Snowflake if you want to. And we have pipelines to get data in. So there's lots of useful ways to get data in and out.
Awesome. David, I'll give you the last question before we go on to the raffle winner. There was one question that was about saying, while embedding the tweets, are you also embedding media? And it just made me think about, like, you know, maybe not this demo specifically, but are there other demos where you work with image data or other data? It was kind of interesting for me to think about, so I wanted to pose that one to you.
To be honest, we haven't done a ton with like other media yet. Like like, I mean, candidly speaking, it feels like it's still like even earlier than text, or like, and so we haven't necessarily gone down that path too much yet. In theory, like, the platform is built modularly to support these types of things, but it's just not something that we have worked on too much.
All good. Okay, great. With that, we can move on to the AirPods raffle announcement. But before I say that, as I mentioned during the intro, on Thursday of this week, we're going to be presenting how to build a full stack AI app in React with the Elegance SDK. Akmal, I wonder if you could pull up that final slide of your deck so that folks can see that. I put the link in the chat. Feel free to register. The team is going to be showcasing a hands-on demo called Books Chat, where you can do a React app in just a few minutes, build it. It allows you to interact with the uploaded books data. It's a really cool demo. Feel free to register for that. There's a QR code on your screen. There's the bit.ly link in the chat. And then for the announcement you've all been waiting for, today's AirPods go to Anthony Kaminsky, head of data analytics. Congrats. Thank you for joining. If that's not you, don't give up. We're going to announce one more AirPods winner by the end of the day for anyone who tries out David's demo. We're going to be emailing that out. I think I put that blog post in the chat. I'm also going to be emailing it to everyone who registered, so you can follow that along and hopefully win an AirPods as well if you try it today. Thank you, David, Akmal, and Eric. Awesome presentation, demo, and Q&A. And thank you to our audience for joining us. Have a great rest of your day. Bye, everyone.